Find the minimum of f of x on the interval 1/2 to 2 inclusive, given that f of x equals, x ln of x minus 1. That kicks it up a notch. Okay. So I'll start. I always like to start max and min problems with drawing a little table. So we know we're going to be between 1/2 and 2. We know that f of x, I know it's written up there, but I'm going to write it again. I wonder why I am writing it again. I could probably get away with not doing that. That's okay. Already done. Okay. So it's going to be easy to take the derivative of negative x. That'll just be negative 1. But we're going to have to do the product rule for x ln of x. And even though I am reasonably confident I can do it in my head, I won't, because I'm not that confident. Okay, so the derivative of natural log of x is 1 over x. And the way I remember that is kind of by trying to do the integral. So if you do 1 over x, that's the same as x to the negative 1, which would give you integral of x to the negative 1. And first thought is, the power rule. So I'll do x to the negative 0 divided by 0. Because you do negative 1 plus 1 and then divide by that. Well, you can't divide by 0. World ends, terrible things happen. Apocalypse and such. And so that's completely wrong. And the way that what I remember is then kind of sort of correct, that other path to take is natural log of x. And so that's kind of the mnemonic I use to be like, okay, the integral of 1 over x is natural log of x. Therefore, the derivative of natural log of x will be 1 over x. And when you do the integral, you actually have to do the absolute value signs. Derivative, you can start with natural log without the absolute value signs. That's okay. Not relevant to this. Moving on. Trudging on. Soldiering on. Being tough. U is x. U are x. Okay, v prime, 1 over x. Ooh, interesting. Should have seen that coming. U prime, 1 v natural log of x minus 1. And then that's just from there. Equals, I should have known this. The integral of natural log of x is x ln of x minus x. You got me. Yeah. 1 minus 1 minus natural log of x. X minus natural log of x. Yep. So we get negative natural log of x. Make sure why is there a negative there? That's supposed to be a plus. Terrible. Okay. U prime. There we go. I'm losing it. My edge is all dull and rusty. Natural log of x. Okay. So f prime of x equals natural log of x. We're going to set that equal to 0, which implies that x equals 1. Because the natural log of 1 equals 0. Another way to see that is if you take both sides to the e natural log of x equals x, which equals e to the 0, which we know equals 1. You can also just graph it on a calculator. It'll show up. Okay. So, 1. And if not, it's just something memorized that... fine. You're right. We should go to the... e to the x. There we go. You see right about... I'm going to say it's about 1. So... Does that make sense? I think that makes sense. Oh. There we go. Natural log. Wolfram writes log. It's equivalent. Is it? I think so. So about at 1 you get 0. Reasonable? Maybe? maybe? You're probably convinced by now you just want me to move on. It's okay. Okay. So, 0. So if we plug, so that's going to be our critical point. We also need to plug in the endpoints though. So if we do 0 real quick, we have f of x of 0 times natural log, 1 natural log of 1, which would be 0, minus 1 would be negative 1. 1 times 0 minus 1. Yes, negative 1. Correct. Now we want to plug in 1/2 and 2. X ln of x minus x. So we have x ln of x minus x, and we're going to plug these in for 0.5. Was it 0.5 or was it negative 0.5? No, but it was 0.5. Okay. We get negative 0.847. Negative 0.847. Which is negative, but not as negative as negative 1. So we're good there so far. Now we're going to plug in 2. And you can just do this on your calculator. Using Wolfram is using a way more powerful tool than I need for basic calculations like this. Negative 6.14. Negative 0.614. I think it was 0.614. 0.614. Yep. And so it makes sense then we're doing minimum, right? Minimum. Boom. So if we're looking for maximum, we'd be like, oh, it's at 2. It's at one of our endpoints. But it's not. We have negative 1 will be our minimum for this. Find the minimum. Boom, boom, boom. Yes. So that's how we do the minimum for this kind of problem.